Hello friends, welcome to my project for Google Gamma 3 and Impact Challenge. I am Ravik Singh Digola, and this is an AI-powered mental state analyzer, a prototype to build to address one of the most critical and undiscussed issue in today's world. Mental health and awareness, specifically in rural areas and undeserved communities. This project is inspired by my personal tragedy. One of my family members lost their life to depression. In my hometown, an 8th-tier city in India, access to mental health care is extremely limited and awareness is lower. Through this tool, I am aimed to bridge the gap by using AI powered video analysis to detect the emotion cues and provide the early indication of mental distress. Let's explore how multi AI model and Gamma 3N can make the meaningful differences. So, what is AI powered mental state analyzer? So, the key idea is an innovative Streamlit application for automated mental state assessment from video. Core functionality includes analyze speech, interpret visual expressions and body language, synthesize multimodal data using advanced AI, generate comprehensive, easy to understand report. Disclaimer: AI interpretation not for medical diagnosis. Consult professionals for health concerns because it's a prototype. Power of multimodal analysis. Concept is simple. Human communication is complex, involving both verbal and non-verbal signals. So, for using that, it benefit like holistic understanding by combining what it is said and how it is said, and how the person looks. It also understand the richer insights by capturing the subtle clue that's missed by the single modality analysis, and it also improve the accuracy by doing cross validation from different stream, using the information of different stream. And if I want to like include some examples of the clues which it captures, like some in case of like audio, you can say like I feel hopelessness, or I'm in misery, like that. Or for like visual analysis, like visual information include like the facial expressions, a subtle change in facial expression like anger to sad, or the eye contact, unusual eye contact, or like that thing. So these were the information which uses by our model to analyze the mental state of a person. Technology stack. So here we are describing all the technologies which are used for building our AI-powered mental state analyzer. So for front end, we use a Streamlit app because it's web-based UI app, easy for upload and easy for result visualization also. And for libraries like for audio video analysis, we use FMPEG, which is efficient for video segmentation or audio extraction, and OpenCV for extracting the frames because it is easier for analyzing for visual analysis. And yeah. And next we have audio transcription. We use this OpenAI Whisper model. We use this base size model because it provide good quality of Hindi transcription. Um, we, al- we also added fallback if like if it's failed to load medium model, then it will go with base model. And for OLAMA, we use this Gamma 3N model using OLAMA framework. So we use this multimodal LLM for visual summarization by like describing the visual expression of a person or person body language in the given image or video. And text-based LLM for like synthesizing audio transcription and video summaries to like categorize the mental state of a person. The analysis workflow. So this is the entire workflow which are used by our AI powered mental state analyzer. So let's understand the each component of the workflow. Then we go to this entire workflow for complete understanding. Okay. So there's a segment called upload video or video upload, which would be done by Streamlit app, and then we done a video segmentation using FMPEG, which divide the video into 4 minute video chunks for our analysis purpose. The 4 minute chunk we does a lot of experimentation on different size of video chunk. We found that 4 minute chunk is very suitable for quality content generation by LLM as per chunk video segment. Okay, next for internal chunk processing, uh, for each segment. For visual analysis, we uses OpenCV to extract the frames, and then use a Gamma 3N model. It generates the summaries based on the visual cues it found on the extracted frames. Then for audio analysis, we use this FFmpeg library, which extract the audio. And then using Whisper model, we generate the transcription based on the given audio. Then multimodal synthesis, where we basically combine the generated transcription and visual summary uh, generated by Gamma 3n model, and then we fed all this information to Gamma 3n model, and then Gamma 3n model describe the mental state of a person based on the given input chunk, either it's normal, depressed, or having any suicidal possibility or not. So this process repeat again by breaking down the video into 4-minute chunk until the entire video is not over, and then it will generate the downloadable report which can be downloaded easily. So yeah, these are the theoretical understanding regarding the each component of the workflow. So let's jump to visual. So here we upload the entire video, and then it internally it break down to 4-minute chunk, and then it does visual analysis using Gamma 3n model by analyzing the getting the visual understanding of a person in the given frame, their behavior, their mental attitude, etc. type of things. And for audio analysis, we generate the transcription using the Whisper medium size model, and then combine all the information. Then we again give it to Gamma 3n model, which try to predict the mental state of a person in the given 4-minute input chunk. And this process report repeated again and again until the entire video is not over. And then it will give the final report, which describe the mental state of a person on the entire video. Efficient processing, segmentation, and chunking. So major challenge we faces while processing large videos, because large videos are resource intensive. So the solution we comes up with hierarchical segmentation. So for like in analysis segmentation, I will describe that the in my Streamlit app, the parameters for like video chunking is configurable. It's from 1 minute to 10 minute, and that basis the videos are breakdown into manageable chunk for LLM analysis, and speed of the frames were handled by FFmpeg. Okay, one more thing I want to add, that for frame video frame analysis, there's we basically select the number of frames in the given entire 4 minute of chunk, because processing all the frames in 4 minute of chunk is very resource intensive. So I select 5 frames in 5 equidistant frames from these 4 minute chunk video for processing it, so that the we can reduce the computational cost while processing each 4 minute chunk. So this point I want to include on in that also. Next, we move on to internal chunks. So here also the we also perform audio segmentation, which we limit from 5 seconds to 30 seconds, uh, that you can manage. But in my cases, I set it to 10 seconds, because use making it 10 seconds give me better transcription while using Whisper medium model. Okay, and we also provided the progress bar for tracking the overall video processing, and also provided internal progress bar while tracking the internal progress of the processing of the internal chunks. DPI analysis, audio and visual. So for audio transcription, we uses the function named transcribe audio with Whisper st. Okay, so its main aim is to like extract the audio from the internal chunk, and uses open AI model, which is medium model, for highly accurate speech to text text transcription generation. Okay, and it also identify the spoken content, including sentiment and key phrases. This was the function, that is transcribe audio with Whisper T. So let's describe this also piece of code also. So here we set global whisper, because for subsequent call we don't want whisper model to reinitialize. That's why we set it global. So if it does not found none value, is it's found none value, then it will load the whisper model. And if it fail to initialize that also, then it will say that whisper model is not initialized. And then it will go to the try block, and where we pass the word audio path and the language, which is Hindi. which we are using, and we call the model with dot transcribe. And then it will generate the key pair with text, which include the all the transcription text which are generated by the Whisper model. And if it not initial, then it will also again try to transcribe the given audio file to generate the transcription. If it fails again, then it will say that no spoken text were detected or like that thing. Otherwise, it will return the transcription text. And if in first attempt it will success, then it will return the transcription text. If any error occur in try block, then it will shows that it will fail to load the model and fail to generate the transcription using this model. Okay. Now next go to next part, that is visual summarization. So here we describe a function called get visual summary from Olama. So its main aim is to extract the keyframes from the internal chunks and then uses Gamma 3n to describe the facial expression, body languages, and activities. Okay. It also focuses on non-verbal clues related to emotion, state, and engagement. Okay. Let's describe this function also. So get visual summary from Olama accepts the image format base 64, and here we also describe the chunk start time and end time. If base 64 image is not found, then it will say that no information found in the segment. Otherwise, we describe the prompt where we describe the personal visual expression, body languages, and activity it should describe in the image from this time chunk to this time chunk. It will focus on the cues, emotion, and energy levels and engagement of the person. It will keep the summary concise because we don't want long length of processing of the text values by the LLM. So we make it short of 50 words for neutral, and it will also state the clear visibility of the emotions so that it should be concise and correct. Okay. So here we pass the prompt template where we describe a role, and the in content we pass our prompt, and images where we describe our images, base 64 image, and then we call our model using olama.chat where we describe a model gamma 3n, and then we passes our prompt template, and here we describe our context length is 4096. I've experimented with that. I found that 4096 is suitable. More than that will degrade the model performance. So here it return the output in the message content dot strip. Okay. If this any error occur, then it will say the visual summary failed due to LLM error. So yeah, this was the regarding the audio video analysis. Synthesizing insight for final categorization. Okay, this includes some point like consolidation, where all audio transcription and visual summaries from a complete segment are aggregated. Second is LLM rule. Here I describe the function name analyze overall mental state categorized. So this performs the entire LLM rule. That entire function will be discussed during code walkthrough. So let's jump into the internal points of LLM rule. Okay, so it's a powerful text-based LLM which uses Gamma 3n with Olama, which receives the consolidated data, and then using prompt engineering, which helps in guided to provide the precise one-word category, that is normal depression, suicidal possibility, followed by the concise justification. Third, it identifies an explicit verbal clues that like I want to die, I'm in misery, or like that kind of um, clues it will try to find out, which is critical for critical classification. And warning system which provide automated alert like whether it detects any depression or any special suicidal, especially like suicidal categories. Comprehensive analysis report. So in this section, we are trying to discuss some of the key points regarding the report. Okay. So first point is key metric, that is total segment processed category breakdown. Okay, which include number and percentage of the segment classified as normal, depression, and suicidal possibility. Okay. Second point is detailed table, which includes segment time range, predicted mental state, justification from the LLM. Okay. Third point is download table report, which include full analysis of the report available as .html file for offline review and record keeping. Report walkthrough and original source. So in this video, I describe regarding the video as well as original report. Okay. So let's go through this link. So just me here and give it there. Okay. So this is the
कोर्ट
So
का
this
समय बर्बाद
much
करना, मैंने अपने वकीलों पे इतना खर्च किया, आने जाने में इतना खर्च,
regarding
की कोई जानकारी नहीं थी।
this.
उसने अपना एजुकेशन क्वालिफिकेशन
Regarding his mental state. Okay. So I uses the complete video for my report generation. Okay. So this is the report which I generated using the entire video. So here it described the AI powered mental state analyzer. Video name, that is Atul Subhash. Generated time it shows, and the video duration it shows in the form of seconds. We uses 4 minute segment. So total segment it got is 21. Segmented process is 21. Okay. Here we do some category breakdown, like which include, there are like 6 segment which detect having suicidal possibility, 15 segment it detect depression. Normal state it doesn't find any normal state. Here we do some visualization using pie chart, where you can see 71% of the depression category and 28.6% of suicidal possibility. Same with this bar graph also. And here he also provided the tables which include segment by segment details. Here you can see from 0 to 4 minute segment it provide suicidal possibility, as well as it provide justification on what basis it will tell. Similarly, for all 21 segment we included that a disclaimer regarding this thing, that it is not a full-fledged describable tool for medical purposes. We have to consult with doctor for using this thing, because um, we can't say that that LLM is having like great expertise on the medical fields, because it's very sensitive, and we should be very accurate regarding this thing. If anything goes wrong with it, then it will like life and death case for some person. So yeah, this is the just a prototype which I discussed to make it efficient and make it reasonable for the person, available for the person to understand their mental behavior using the video. Okay. So yeah, how to run the analyzer. So here I want to discuss some points which are useful for running our AI-powered mental state analyzer. So first point is prerequisites. So we require a package which we have to install and add to the path. And second is Olama, which you can download using Olama from olama.com. Third is Olama models, which you have to pull. In my case, we have to pull Gamma 3N. Second point is Python dependency. So you have to install Streamlit app because it's Streamlit based app. Then Olama for pulling the model. OpenCV Python headless because we don't want any GUI integration based OpenCV. Okay, so we that's why we install OpenCV Python headless. NumPy for our internal calculations, and Whisper is for audio transcription model, and Streamlit Extra we use for like tabular report generation uh, for our final report which we generated for our complete analysis. And fourth point is Streamlit configuration. So here you can do internal configuration changes by changing max upload size to 2000 for larger video files upload, larger video upload files, and either or you can not do any like internal changes. You can run directly on command where you have to type the streamlit run app.py, and here you have to describe the server dot max upload size to 2000 for increasing the upload max upload size of the input file. Okay. Fourth point is execution. You have to save the file as app.py, and then run on the terminal as like streamlit run app.py. Future enhancements leveraging specialized model. So let's talk about first current model. So currently we are using Gamma 3N for its general purpose multimodal capabilities and excellent local execution by Olama. Typically runnable on devices with 8 GB VRAM without internet connections. Potential improvement we can do is by replacing Gamma 3N with Medgemma, because integrating Medgemma 4B have certain advantages on our AI powered mental state analyzer. Firstly, like it provide enhanced medical context understanding. Okay. Secondly, is that Medgemma is specialized variant of Gamma 3. So it was specifically trained on vast area of de-identified medical text and image data, which include like X-rays, chest X-rays, dermatology images, and histopathology slides. Okay. Third advantage is that it offers superior performance for medical imaging, interpretation, classification, and clinical reasoning tasks. And It also provide like more nuances inside for certain mental states that have like psychological and symptomatic manifestations. But there are certain disadvantages I faced while deploying Medgemma 4B locally. So that I will discuss on my next slide. Limitations and challenges with Medgemma for me. So here I will discuss some of the reasons why I not go with Medgemma 4B instead of Gamma 3N. So let's discuss first point, Olama availability. As of now, Medgemma 4B is not officially and widely available directly on Olama public library. This means running it locally is more complex and might require manual conversion or unofficial community efforts. Second point is resource optimization. So while Gamma 3N, which is a 7 billion parameter model, is efficiently optimized and widely available on Olama in quantized format, allowing it to run on like devices with 8 GB VRAM or less. While in Medgamma4B currently lacks similar readily available and highly optimized Olama quantization. This means even though it's a 4 billion parameter model, running it locally might demand significantly more VRAM, might be 16 GB VRAM or more than that, or require more complex manual optimization, making it less accessible for like standard consumer hardware compared to Gamma 3N model provided by Ola. Okay. Third point is accessibility. Currently, accessing Medgamma typically requires signing up agreement through platforms like Hugging Face or Google Cloud Model Garden, making local unrestricted deployment more challenging. Okay. Fourth point is now let's draw the conclusion. While MedGamma4B offers promising avenue for deeper or medical tune analysis, but it currently lacks of like direct Olama support, and higher hardware requirements present significant hurdles for immediate integration into our current AI-powered mental state analyzer pipeline. Future efforts will monitor its availability and optimize for like broader deployment. So yeah, that's all. Thanks. Hello friends, this is the code walkthrough of my AI-powered mental state analyzer with using Streamlit. So here I'm importing some package that is Streamlit uh, for for like describing my web page as a Streamlit based app. Here I'm just importing the Olama for importing my model. Here I'm importing CV2 model for, of course, for visual processing. Here base 64 the Gamma 3 model accepts. So I import that to import the image in the form of base 64, which it takes as input. Now subprocess for running the external commands like ffmpeg. Okay. Now here I'm putting OS for path, relative path configuration, and whisper model for loading the whisper model, torch for doing internal processing, and yeah, counter for counting the categories, and datetime value for like selecting the chunk frames, shooter for copying and deleting the files, regular expression for robust output, because sometimes you know that some error occurred like while generating the output. So to separating the categories and their justification, we use this regular expression here. Plotly for plotting the uh, that pie chart plot and paragraph plot, we use this plotly. Data frame for like PD data frame we are using for creating the data frame for like a different time stamp with categories and their justification. Okay, mental state categories and justification. Here I'm also importing Streamlit extras data frame explorer for like uh, better visualization of the table in the form of data frame in while producing the report. Here I'm not using tabulate because this Streamlit extras data frame explorer provide a beautiful report summary generation in compared to tabulate. Okay. Okay. Now let's go to the configuration part. Here is it. Okay. Fine. So we set the global whisper model none, and whisper model size medium. You can set it base small, but in my use case, medium works fine for me. Here I also created the temporary video processing directory where I save the uploaded video as well as its chunk audio and video frames while processing. Okay. And whenever this processing done, it will automatically delete the data. I will discuss at the end of the this code walkthrough. Okay. So first let's discuss the this function extract audio segment. So in this function we passes video path, start timestamp and timestamp and audio output path. Okay. So here I am passing ffmpeg where high where hyphen I refers to the input. Here I am passing video path. SS refers to the start time of the given audio, given video, and here like two refers to the end time of the video. We basically passing like disabling the video recording because we want only audio, and here AC we set at 1 because we want mono channel audio. Okay. 16,000 this sample audio sample rate which we set because our model accept well optimized for that, so that's why we set that. Okay. Now we also set some of the codec format for like audio, which is pulse code modulation format, which give us better, like I would say, better raw audio output. Okay, and here we are passing over output path where we want to save all these things. Okay, now we are running this subprocess.run command where we are passing the command entire fmpeg command. We set check is equals to true means it should run, and capture all the output. It should be also true. Text would be also we consider as true, and we also set the UTF encoding format should be UTF-8. Okay, it will run the command and capture the all the audio based on the time frames and save it in the output audio path. If any error occur, then it will returns the error in extracting the audio frames. And yeah, or if the fmpeg is not and fmpeg is not working, it will gives the error like fmpeg is not installed or like that. Now let's jump to the next function, that is load whisper model. Okay. Earlier, before that, we have passes some decorator. This is Streamlit decorator, Streamlit cache decorator, which is named as Streamlit.st.cache resource. So its main work is like to uh, whenever if the restarts, so it will store all the loaded model. Suppose this function is calling a model, so it will not we don't have to reload the model. It will store that model into the caches. So whenever you rerun the app, so it will not reload the model. That's the main purpose. I'm passing it that's st.cache resources. This is very useful while because it saves the computational resources while rerunning the entire app. Okay. So let's now describe the entire function, what it does. So load whisper model, here we describe the device. It will check either it's CPU or GPU. If it found GPU, then it will run CUDA, otherwise it's running CPU. Here I'm describing the info bar where I'm describing the model, like loading the whisper model. It's loaded, then it will shows the model name and what device it used to load. Now here we go to try block where we try to load our model, where we describe a model name as well as device, which device it used to load it, and then again we add the progress bar regarding that loaded, whether it loaded or not, and then it return the model. If any error occurs, then it will say that it faced error while loading the model or due to some internet connections or like that thing. But I downloaded that model locally, so there's no like internet connection should be required while running the entire model. You can run it without internet connection also. So, but I added like if some any kind of error occurred, then it will show this error and then it will try to load the base model. And if it fails on loading base model also, then it will give me error and return the statement at fallback base model will also fail to load, and then it return the error with description and return the model none. So yeah, this is regarding my load whisper model function. Now let's jump to the another function named transcribe audio with whisper st. So this function I already explained in my PPT slide, but now explain it in slight detail also. Okay. So here this function accept the audio path. Here we describe the as a global variable to the whisper model because we said that we want to load that model once. So whenever it find the whisper model function earlier, so it will not reinitialize that variable. It will use that variable automatically. Okay, global variable automatically. So here, if it found it none, then it will try to load the model. Otherwise, it will say the whisper model is not initialized or not found. Okay. Now let's go to the try block where we are basically trying to transcribe the audio. So whisper model dot transcribe is a function which takes the audio path. Here also I describe the language. There's no requirement of p16 is equals to 2 because I don't find any like huge differences while processing that, so I set it false. And one more thing, in earlier function by already processing, we passes these text is equals to true. This is helpful for if you want to like generate the transcription from the audio. That's why I set it to true. And capture is for true for capturing that audio. Okay. Now let's jump to the function. So here I'm passing the transcribe audio path, and fp16 is equal to false. Okay. Yeah. Yeah, this way. So it returns me the result object, which where in text it contain all the transcription regarding that. We strip that and we return the transcription text. If the transcription text found it none, then we will again try to like transcribe it using audio path and same configuration, and again try to do it with strip to extract the all the transcription. If no transcription found, then it will say that no spoken content is detected, or that's why transcription failed. Otherwise it return the transcription. And if any error occur while like loading the model or anything like generating transcription, then it will say that error occurred during like transcription. With that also provided the image like audio path, temporary audio path, which it process. So yeah, that's all regarding the transcribe with audio with whisper st function. Now let's get jump into another function named gets visual summary from Olama. Here I am passing the list of base64 images, chunk start time, chunk end time. If like list of base64 images not found, then it will say no visual information found. Otherwise, we will describe the prompt here. Let's go through it. Describe the person, visual expression, body, language, and activity. So in this image from like starting chunk time to end chunk time, it says focus on the cues that suggest their emotion state, energy level, or engagement. Keep the summary concise under 50 words and neutral unless the specific strong emotion are clearly visible. So here I experimented with like 100 words, 250 to 50, but I go with 50. That gives me good result, so I go with that 50 words. Okay. Now I'm calling the prompt template where I'm passing the message where I'm describing the role as a user. Content we are passing the entire prompt. Images where we are passing the list of image like images with base64 format. Because base64 format model generally accepts gamma 3 and model generally accept in base64. So I give it as an input list of images of base64 format as an input. Now here I give the try except block where I describe the responses like oh llama.chat where I describe the model name and the like input prompt template. And here I also experiment with context length, so I set it 4096. You can experiment with that. So it will return you the uh, response object where inside the message or the content you got the all the responses which are generated by the model based on a given input. If it fails, then it will say visual summary failed due to LLM error and this kind of things. Okay. So yeah, this is regarding the get visual summary from Olama function. Now let's jump to the next function named video to multimodal chunk, and it accept video path, chunk duration in second, frame per chunk, and internal status holder and internal progress bar holder. These are the two status bar holder where internal bar holder shows the entire chunk processing in the form of progress bar in our front end, and internal progress bar shows the entire video processing progress bar. Okay. So here we call cv2.capture to capture the frames from the entire video. If it shows any error while capturing it, then it shows that could not open the video. Okay. Then here we get the each frames per second. Okay. Now here we are basically get the total number of frames in the video. Okay. Now here we are calculating the video duration in seconds by dividing the total number of frames with FPS, current FPS of the video. Okay. Now here we initialize the chunk list and set the current time span time 0. Okay. Now here we initialize our progress bar where we show that processing of internal chunk for segment should be started for like particular video chunk. Okay. So that we display here using that. And here we calling the while loop, where we are basically set the condition if like current time is like smaller than duration total video duration times time, then it will this while loop run again and again until that entire video is not completed. Okay, this is the logic regarding that. Okay, now let's uh, jump inside the like while loop. So here I'm describing chunk and times in second, where basically I'm taking like current time when adding it with uh, chunk duration, which is 4 minutes. In second, you can count it that, and duration of the video also. So it will give minimum amount of time. It will give me that 4 minutes of and timestamp will be for the given chunk. Yeah. Okay. Here I'm describing the base 64 image list. Okay. And here I'm passing the uh, getting the starting index of the frame and end index of the frame. Okay. Here I am describing the logic where if the like frames that we have to capture and frame indexes that we have to capture, okay, it will this function analyzes if the frame per chunk is greater than zero. Of course, it will greater than zero. Otherwise, there will be no video. So yeah, if it greater than zero, then it will check the condition that if it like video is like shorter, uh, uh, video is like a short short or end of the video. That in that case, that it will also check the condition that start frame index should be like smaller than total frames. Then it will save the frame indexes captured. Uh, Means it will save the frame in the frame indexes to capture. Okay. Uh, yeah. No, it will save the indexes in the form of list in the frame indexes to capture. Okay. If like video is short, then in that case, this logic would be handled. And similarly, we give the same logic where we calculate the step size for based on the frame per chunk by describing the length of this video frames and divided it for frame per chunk. We get the step size, and then we go in the frame per chunk. Okay, and here we describe the step size index, and then if the index is smaller than it will total frames, then it will uh, append these indexes in the indexes to the frame capture other, and after that it will sort the frame indices. If it found any duplicate, that would be removed. And in this case also we set if that last, suppose it's on last chunk where the video size is smaller than the format, then in that cases same we logic we covers that it will smaller than 12 frames, then it will we will get the indexes from that frame. We directly return the list of the indexes directly. Okay. So after getting the all the indices which we want to capture based on the uh, frame per chunk we set, in my cases I set it 5 because I want to like take only 5 frames on the 4 minute chunk, which is good to capture the all the visual scenarios. Five equidistance frame from the 4 minute chunk is good enough to capture all the visual info. You can do an experimentation. On my experimentation, I found it like it is very good to capture that mental state. Okay, so yeah, after getting all the like indices of the frames, let's go to like the next for loop where we do the frame indices and then extract the all the captured frames from the particular indices, and then we try to convert into like base 64 image format and UTF-8 8 encoded decode format. Okay, now if it error occur, then it will say that can't read the indexes at that particular video chunk for the given frame, and it will break the loop. Otherwise it will run and append all the base 64 image formats in UTF decoded format. And then we also describe our audio temporary path where we want to like extract the audio for processing. Here we describe the transcription text where we call our extract audio segment function. We pass video path as well as time frame on which we want to extract, and the audio temporary path which we describe here relative audio temporary path. and here it will save the audio, extract audio from this temporary path, and then we pass the audio input path to transcribe audio with whisper st function, which basically giving us a transcription regarding that particular audio. And after getting all the visual and transcription based information, we pass it to the visual summary, where it uses all the information regarding the base 64 image chunk, and give us the visual summary regarding it on the base of this timestamp. Okay, so it will generate the visual summary. Then we, as we earlier described, the chunk list in the form of list, where we describe it as a like a dictionary, where it describes start timestamp and end timestamp, and the transcription which is generated by the audio and the visual summary. And this entire chunk with dictionary element contain all the information regarding each chunk. And then here we set the current timestamp to like chunk and timestamp. And yeah, so in this way it update the current timestamp and based on the processing chunk time. Okay, so here it update the progress bar according to the chunk we processes. Okay, and and here we are also like updating the progress bar for our internal processing chunk. Like it says like 100% chunk processing it done. So this entire loop repeated itself until it will cover all the entire video, and all the information, like you see that it will save in the chunk file. And now then after all covering all the video, then it will release the uh, capture capture info, and then return with the entire chunk with the all the information. So yeah, this is the all the functionality regarding the video to multimodal chunk function. Yeah. Okay. One more thing I forgot. In video to multimodal chunk function, the while doing the audio processing, there is temporary directory which is created. While doing the complete audio processing, it will also remove the audio file from the directory, which is as you know earlier we are creating this temporary video processing, where it save the audio processing directory also, audio processing folder also, and it will, after doing the processing in this line, it will also remove the audio chunk from the particular directory, temporary video processing directory. Okay, this thing I haven't included in my explanation regarding this function. So yeah, that I included here. Okay. Now let's jump to the next function. That is analyze overall mental state categories. Okay, and categorize it. जो भी categorized. So here I am passing full transcription, full videos, visual summaries. Here I am describing the model Gamma 3N, and here the max token length I experimented with like 3, 4, 5,000, 7,000, but I found 6,536 is suitable for me, like any like different kind of videos with different lengths. Okay. Now here I also pass the analysis status holder, just for like updation of the status, nothing else than that. So it set default set none. Now let's describe the prompt here, which I created while combining the both like audio transcription and then visual summary. So here I said you describe the like AI assistant specialized in human behavior and mental case state clues. Right, so here I describe the task like to classify the mental state based on the transcription and visual summary. Here's the complete audio. Here I describe the audio start, and here describe the audio transcription, and here the audio end. Now here's the visuals information and with timestamp from the video segment. Okay. So here I put the video start, visuals summary start, and visual summary end to describe which part to describe the visual summary. And here I describe regarding the what are the consideration it have to take. Consider all the information that determine the overall mental state of from the video segment. Category must be like your response must start with the chosen category. Only on the like first line it will describe the category. Okay, category must be chosen with exact word like normal, depression, and suicidal possibility. That three category only I chooses for my AI powered mental state analyzer. And here I also describe after that, after the first line, also just give me like brief justification regarding it on one or three sentences, like why it chooses that certain category. So also maintain the interpretability regarding the result generated by the LLM model. Okay. Focus on the demeanor, tone, voice, tonality, expression, and overall coherences also. And these are the minute details which I add. If there is any explicit verbal clues that depression, I feel hopelessness, I can go and suicidal identification like that, or like I want to die, I should end it, and like that thing. Then it will uh, analyze that hints, and based on that, it will generate this three possibilities of mental state which I suggested here. Okay, and recognize this is an AI interpretation, should not be used for diagnosis because this is a prototype. After um, giving the understanding to the medical team, then only we can use it, because this is just a prototype. Because you know that there is a risk of life and death. So yeah, this is, and the person tone should be stable, and the expression indicated the active engagement. There's no sign for distress. It should be mentioned. The things you should mention is that tone should be stable and expression should be like active. If any distress found, then you will track that emotion, whether it's like destabilized emotion like depression or suicidal possibility. Okay. So yeah. Now let's go to here. Here it will try to after getting all the information, it try to count the length of the tokens. Here, if it found none, then it will reinitialize it, that estimated token it found in here at the analysis bar. Uh, and yeah, if estimated token is like greater than max folder, then it will gives the warning that it exceeded with it. Okay, and here we passes the message for Olama template, where I'm passing the combined prompt template from it, where I describe the role and the combined prompt template, which combined prompt which I am passing in the prompt template. Now here I am also reanalyzing the status folder, where it send me that it will also update an info regarding the sending the Olama to like categorize the model mental state, for the also describing the model name here. So it will give the info like all the categories regarding the input chunk, all the things were found. Now it will goes to the model for a final analysis. That info should be displayed in the front end. That's why I put it that. Here I'm passing the response that olama.chat, where I'm passing model name and the message of the olama, which contain all the information regarding the prompt and the information of the additional information whatever by passing. In here where context length I'm passing 6536. You can experiment with it. I found it suitable for me. So now we return me response object, and then we inside the response message and content uh, in content folder or content side, it will give you the response regarding the uh, model responses. So that would be written. If it not found, then it will say that error occurred while doing overall analysis or this kind of thing. Okay. So yeah, this is the demonstration, or you can say code walkthrough regarding the analyze overall mental state categorize function. Okay. One more function I'm also describe here. It's a short function that is get capture video duration. This is just for capturing the video duration for displayable purpose. So here we are capturing cv2.video capture, where it captures the video. If video not captured, it will return zero. Here it will set the frame per second in that entire video, what FPS would be there, and then he would count the total frames, and then we try to identify the duration of the video using the total frames and FPS. And after counting the duration, then we release the capture function and then return the duration of the video. So yeah, here I describe two functions, that is analyze overall mental state categorize function, and as well as get video duration. Okay. So this is the main part of our Streamlit based pipeline. Okay. So here I'm setting the config, where I'm describing the title as mental state analyzer and setting the icon and some layout that I added included here in set page config. Here again describing the title like AI powered mental state analyzer. Here I added some information regarding this pipeline, and this is the separation line, like which acts as a separation line here as markdown. Now here the slider bar controls I have added, which is describing the slider. Its default value should be set to 4. And this slider describes the video chunk which we are doing performing, that is 4 minute. So I set for default value 4, and like minimum value should be 1 to 10 minutes, and you can like select the bar from 1 2 minute 3 minute 4 minute up to 10 minute. Okay, now this also count the segment duration in minutes. Whatever the slider you select, it will convert that 4 minute into like seconds, so that which was easier for our calculation related to calculations. And similarly, for like audio chunk, we have set default value to seconds. This is slider bar regarding the audio chunk. Default value set it to 10, and you can set it like 5 seconds to 30 seconds. Simply in the range of 5 step, you can add like 10 second, 10, 15, 20 up to 30. Okay. Now here is the again slider bar regarding the frames. You are selecting in the video frames. So like 4 minutes video, I have selected only for 5 frames, but you can select from 1 to 10, 10, 1 to 1 to 10 frames, where I provided the step size one. So you can select from 1, 2, 3, 2 up to 10 frames, whatever you want. So in my case, I selected 5 as a default. This is the slider bar where I like describe some of the info regarding it, like ensure the FFmpeg installed and accessible, because we have to use this for accessing of frames, like video segmentation and this kind of process. So yeah, these are the additional information I provided here. Now this is the markdown for separating it. Yeah. So this is the main content area. Here I describe the upload file functionality, where I uses a file uploader, which helps to upload the video files. So here I describe some of the formats which it supports, and here I also describe the extension of the video files which it supports. Okay. Here I describe if functionality if the like upload file is not none. Generally it was not of none because you are trying to upload the file. So it will make the temporary directory which is used for video processing. And here basically we join the relative path, we create the relative path for the video file inside the temporary directory, and then write the video inside it. Then here it displays the video and says the file uploaded successfully. Basically, it write the like entire video file into that temporary directory for video processing, and it says upload successful. Then here I describe the button that start when you click it, start the analysis. Here after clicking it shows analysis in progress. Here I provide some progress bar as an empty folder before initializing it. Now here I'm initializing the progress bar placeholder 0, and here I describe some description that overall video processing is 0%, current segment of internal processing is 0%. Okay. Here I am calling the function name get video duration, where I'm passing the video path. So it will give me the duration of the video. If the total duration of the video is 0, it means that video is either corrupted or video is not video is like corrupted, or video is anything something wrong between in the video, okay, given video. So then it will throws the error and says video is empty, and it will also remove the temporary directory and stop the Streamlit app. Okay. After that, if like if there's no error came regarding it, then it will update the segment status container progress bar with giving the description that duration of the video, as well as which segment it's trying to analyze, which video segment it's trying to analyze from the given video, that it will display. So after updating the segment status container with like video duration and that analysis of the segment which we displayed here, after that we initialize some of the variables like current segment start time with 0, segment count with 0, and all segment result for report that should be initialized as list, and similarly like predict category list that is also initialized as list. Here I am describing the while loop, where I am describing that current time segment which is representing the current time segment, which is around 4 minutes. That should be like current time segment chunk of the video, which is currently 0. If it's less than total time duration, then it will be like update 1, which means we are initializing we are processing first chunk segment. Okay. Here I am basically trying to update it like current segment time, which is 4 minutes, which I am adding with current segment start time to describe the segmented video time to get that video chunk segmented video chunk of 4 minutes that I'm describing here. So now I am basically uh, create the temporary video path here where I'm describing the uh, like segmented video chunk in the video processing directory and save it. We're basically saving it in this relative path during time of processing that video chunk. So here I update the processing segment status container with like processing the segment with information regarding the current segment start and end time. Okay. Here I am using the ffmpeg external command where I am basically trying to extract the entire video chunk of like 4 minutes. Here I am basically saying that if it's like if any or error not occur here, then it will say extracting the segment. And here I am running the command and it shows that update the status bar like segment extraction complete. And if any error occurred, then it will basically return me as an update bar as an error status. And it will also try to skip that segment and remove the segment chunk from the video processing directory and then update the timestamp from the skipping chunk time frame. And yeah, and also update the overall progress bar here with also with error it shows. Okay. And here also overall progress bar is updated here that showing the progress. If no file error occur, then it will remove the entire temporary directory and on entire Streamlit tab stops. Okay. So one more question, you think that why we are called using the while loop here also and inside the video to multimodal chunk. So earlier I confuses with that. So here in this outer loop, we are using 4 minute video chunk. For inner loop, we are using chunk duration of 10 seconds because we want a proper sync between our audio and video because we are doing our processing of like audio processing of 10 seconds and we don't want that there should be a mismatch between the audio and video. So that's why it this video to multimodal chunk takes the input video length of 4 minutes and then it will do the chunking of 10 seconds video frames from it so that there should be proper sync maintained between the audio and video files. Okay. So yeah, here after that we like display update our progress bar with placeholder 0 and current segment which it's processing to 0%. One more thing to add on the multimodal, this video to multimodal chunk function returns the multimodal chunk, which contain all the information regarding chunk and its audio transcription as well as visual summaries. Okay, so but we want that audio transcription and visual summary as an input to the LLM model for like giving the category as well as justification. So we have to convert, ensure that it should be in text format. So here we are doing this thing. Here we are describing empty string as a full transcription segment, visual segment. Here I'm iterating the multimodal chunk where it check the transcription audio and audio text or audio transcription audio text here. Where if this like this kind of information was not there, which means we can able to append the transcription audio text here in full transcription segment and visual summary on from that given chunk. Okay, so after like extracting all the full transcription segment and full visual text summary from the given 4 minute chunk, we says that update the container status bar like performing overall categorization for that given segment. So here we are also describing the spinner where it spins in the front end while processing all the transcription and visual segment using this function like analyzes overall mental state where we call the model name gamma 3n with token size like 6536 banks input tokens. Here I am also passing the segment status container for updation which would be happen inside this function while processing. So yeah, after like the processing done regarding the analysis overall mental state, then here we describe as a placeholder predicted category as NA and justification regarding like analysis field or no justification provided. Like the uh, if the function like analyzes overall mental state category function is failed while processing, then it will provided this thing as a placeholder. Okay, and if it does not fail and it will return something that function overall overall mental state category function successful, and we will extract the category from the like from the we are basically first try to split the lines into like 0 or 1. Here we are basically stripping the zeroth line with categories. We are checking these categories are present or not. We are also calling re.ignore for ignoring the cases. And yeah, here I'm trying to match the categories. uh, okay, by setting it lower based on the first occurrences, and then here we are checking if the normal is small cases that is matched with match tags, and it will set to normal. Same for depressions, rare possibility, and a categorize also. Okay, now this thing are set. Now let's move on to justification. To justification with the line, like if it will check the line is greater than 1, then it will strip out the justification from the first line. Okay, now it will also check regarding sometimes like happen in LLM is like that. So suppose if the category is uncategorized, and there's repetition of this category is also also occurred in the justification line also. uh, like uh, like LM produce output like uncategorized because uh, the tone is not perfect like that. So we don't want that uncategorized to be repeated on our justification. So that's why we scrap that uncategorized here from that line justification line, and give the justification as a noun. Okay. So for that handling this thing, we type this if condition, and yeah, if that thing was not there, then it will provided the justification as it is. And yeah, uncategorized full responses as a predict category that we assign here. Okay, and if the LM able to like generate anything other than that, like if it not generate uncategorized categories and not in like it's basically generated something else, then in that case it will provided the LLM did not provide explicit justification on new line. Okay, so yeah, that would be integrated in the justification. After that, like it will update the segment container regarding the updation, like analysis for that segment should be happening, and predicted state what it predicted, and justification what it provided during like prediction. And then all the informations like segment time predicted state that would be important appended in the form of list to the all segment result for report. And predicted category list basically append all the predicted category for the particular segment. Here also we add some warning regarding if any suicidal possibility or depression predicted on that particular segment, and it will give us warning regarding that, because it is critical moment for a psychiatrist to like understand that segment of the video chunk, to analyze the behavior of a person, to because this will give her an idea whether the person is dealing with suicide or suicidal possibility or depression. So that's why I put the warning here. And after processing, it will remove the video from the temporary directory and then update the timestamp here. Here we are basically uh, update the progress bar. Suppose the current time segment is 4 minutes and total duration is 100 minutes, then it will just give you an assumption like 0.04. Suppose that overall progress uh, values like that, then it will update to 4% updation. Okay, and here we are basically put it empty because we want our updation after like suppose 4% has happened in that output of the progress bar, then we want to update the progress bar after 4%. That why we put this all this thing empty to make the updation after that. Okay, so yeah, there is a separation markdown we provided, and here we also provide the subheader regarding the comprehensive analysis report. So let's discuss the comprehensive analysis report. So here I'm calling the counter with predicted category list, which basically return me the category with its number of occurrences in the form of dictionary. Okay. Here I'm passing the like recognized categories which I want to recognize in the form in my report, that is normal, depression, suicidal possibility. Okay. Here I'm creating a list for valid categories for stats, where I'm basically um, creating a list regarding this all the categories, normal, depression, suicidal possibility, which are presented in the predicted category list. Okay. So basically, valid category stats contain the all the predicted category list. Just to ensure that it should be all on recognized categories. That's why I'm using list comprehension. Okay. And here I'm basically trying to evaluate total number of segment using this list, length of list, to get the idea regarding the total valid segments it has. And yeah, here I am basically create a markdown regarding the total segments which I found here. And yeah, again markdown regarding the breakdown of the segments which I found. So if total segment is greater than zero, then it will display the order like suicidal possibility, depression, and normal. Okay. So here I am setting three columns which have suicidal possibility, depression, normal. Okay. And we enumerate to that display order using for loop, where I'm basically try to find the category on this category counts, where if the category is present, then we'll return the occurrence value, otherwise it will return zero. So using this occurrence value, we are basically calculating the percentage, and here I'm basically checking, assigning the call value to the according to the categories. Okay, here I'm plotting the idea regarding the percentage of like that category present on the complete segment. So here I'm describing the category with the count. Count means number of occurrences it happened in that complete segment, and this is displaying in the form of percentage. Now here I'm using for loop for like counting like category counts and this thing, where I'm basically describing if the category is not occurred between these three, then it will give me the percentage of that category which is occurring in that segment. Okay, that it should give. Otherwise, if any error occur in the like if loop regarding that segment, then it says no valid segment found, and protect category it forms some issues with the LLM. Okay. Now here I am doing that side by side segment detail, where I am basically displaying the report in the form of tabular format. Okay. So if like all segment report is found, then it will all 1 minute. If the all segment report is found here, then it will basically passing all the segment report, and it will convert into data frame. Then we are calling the data frame explorer because to make it like data frame interactive. Okay. And it will show the interactive data frame here. Otherwise it will says that no detailed segment analysis should be available here. And if then this section basically displays the data frame in the complete report in more interactive way. Okay. Now let's move on to the generate chart, where basically we try to count if the total segment is greater than zero. Of course, then only it will create the chart. Okay. So here I'm basically again try to like get the categories and their occurrences for the plotation of data. And here I am basically converted into data frame which contain categories as well as count. Okay. Here I am setting two columns because I want to show two charts. One is pie chart and second is bar graph. So for pie chart, we basically passing the data frame and set the value as count and names as category from the data given data frame. And here I am plot giving the title of the pie chart as distribution of mental states, and color map I provided suicidal possibility as red, depression as orange, and normal as green. These are the signals which are showed you in the form of chart while plotting the pie plot. Okay. Here I am basically initialize the st.plotly chart, where I am passing the chart configuration with container update is equals to 2, that is user container width is equals to 2, which helps in plotting that pie chart in the given first column. And in second column, we are basically again passing the same data frame with categories and y-axis. Here I'm basically titled segment count by mental state. Here I'm passing color as a category. Okay. So here in the form of like color bar graph, it basically displays the all the mental state in the given mental state of a person in the given video in the form of bar plot. Here I'm basically passing the bar plot and set it to true to display it on second column of the second column of this report. Okay. The second column of the report. Yeah. Okay. And yeah, here I'm passing basically timestamp. I'm getting the timestamp here and integrating it to the mental report at the time on which it's generated. Now let's move on to generate HTML report. So here I'm describing some of the HTML format for my report display purpose. So here I describe my title as mental state analysis report with video name without extension. Okay. Here are some background adjustment. You can, for more reference, you can refer to w3school.com. Okay. And here I'm again describing the video where I'm describing complete video name with extension. Generated date we describe here. We describe the duration of the video. Also the segment chunk which I used here in minutes. I'm describing it like 4 minute chunk I'm using. So that's why I converted into minutes. Here also summary of analysis where we provided the number of segment which I processed. Okay. Here that I integrated using curly brackets. Okay. Here I am also providing the breakdown, which category breakdown, where I'm again doing the same thing by like counting the categories and their percentage that I integrated on my HTML format report. And if unrecognized categories were found, then it will also integrate that and says that unrecognized error or something like that for the given category because that category was not recognized. Okay. Else if segment is not like less than 0, then in that case it will says that no valid segment found for process for breakdown. Okay. And categories was not present because there's no report would be generated regarding it because no categories nothing would be present because of no segment were present. Yeah. Now let's go to that HTML report content where we describe the visual summaries. Here we are again describing the pie chart and bar graph that we integrate in the HTML format on the content name visual summary of categories. Okay. So yeah, here we integrated all this pie chart and bar graph in the form of garlic bracket. I integrated in on the HTML. If like no bar graph found, then it will again generate no data generated regarding that given input video. Okay. Here we are basically providing our title as segment by segment detail where we are providing the table where we are giving description regarding the each segment and its categories and its justification printed by the model. So yeah, again we are calling our tabular data and converting to data frame. Then we integrate it to HTML file for showing it. If not available, then it will say that segment detail not found or segment this is not available. Okay. And here we are basically doing some adjustment for putting the disclaimer that it's not a like complete app, it's a prototype because it requires some psychiatrist or some medical team to like analyze this prototype that it will work fine or not for the normal use case. If it work fine, then only it would be recommended to use it for public use cases. Okay. Now here I'm adding the download button where I'm basically make pass the complete HTML report and make it downloadable in the form of report file name. And here I'm passing text as HTML, but here I'm downloading it in the form of HTML file. Here I've added some description regarding that HTML file. And yeah, here I'm adding the markdown and says analysis complete here. And yeah, here I'm removing the directory, video processing directory, which I created while processing the video. And here I said the cleaned up the temporary directory, which would be displayed after like video is processed. And here I'm again seeing the suppression markdown here I added, and here's some informative thing which I added here, like subheader regarding getting started with this app. You have to install FFmpeg for the Windows, Linux, Mac OS, Linux. All this information I put it on. And Llama models, how you can visit to the website, how you pull the models, and how you can install the Python dependencies, and what are the packages required. All these things I put it here. You can go through this thing for more info. Yeah, that's all the complete code walkthrough of my Streamlit based app, or I can say AI powered mental state analyzer Streamlit based app. Okay. Okay, let's move on to the demonstration for the our Streamlit. Here I activated our Conda environment on which I want to run my Streamlit based app. Here I type the command streamlit run app.py. Let's enter. That's so background it loading the model, so it will take time to load the page for the first time. After rerun, it will not take that time because it stored that model on cache. Okay, this is the title which we describe on our app. Okay, Here's the description regarding that. Okay, this video chunking is configurable. I set it to 4. Same with the audio chunking, I set it to 10 for by default. You can also play around it. Here the frames which I want to use, number of frames which I want to use for processing the video chunk, that I uh, set it to 5. You can set it to any number according to the processing limit of your local machine. Okay, so yeah, here I'm just exporting my file. Okay, okay. So reason of taking this video is because this guy is taking some wake up challenge. So that's why you can see dark circles and all this thing around it. Reason I'm using it because the video is short for my demonstration purpose, and the facial expression I would test whether my model is that robust to understand its his state, or confuses it with like suicidal possibility or depression. Okay, so let's start the analysis. Here you can see the progress bar is also showing up, but it will not show the progress because video is less than 4 minutes. Okay, here it's describing the video chunk name which it created. Here it also like says the model is loaded to CUDA, and here it's loading the Whisper model and this Whisper model. Okay, here now you can see it takes the medium Whisper model and load it on CUDA. Okay, okay, and here some warning I have integrated, like while installing the package, and or how to pull the Gamma 3 and model using OLAP. Okay, so yeah, you can see that it will get all the transcription and visual summaries from the video. Now it analyzing the overall mental state of a person. Let's pick it. Okay, so now our report is generated. Here you can see our report. So all comes normal. No depression, no anxiety. It also describe the uh, person regarding that is going to the work or he's doing normal activity. So status normal. Here you can see the pie chart and bar graph which is shown here. Okay, and you can click the downloadable report in the downloadable. Okay, or okay, so here when you open it, so all this report you can see here, its video name, generate date, time, segment, okay, process segment, and yeah, complete breakdown regarding this is the report. I'm not going like deeper regarding making you understand regarding this report. For complete understanding, you can refer to my report walkthrough with original source segment, which I included in this video, where I described this video report with video as well as detail regarding the report. Okay, so you can check that. Okay, so yeah, that's all. Thanks.